So in today's lesson, we're going to do physical sciences question paper for grade 10s. And then in this question, we're going to look at firstly the multiple choice question, whereby we're supposed to find the following. They're saying that pulse A is moving to the right with amplitude y meters overlaps with pulse B moving to the left with amplitude 1 over y meters. So remember, pulse A is moving to the right and pulse B is moving to the left. And then the amplitude is given by y meters. And then also the amplitude of B is given by 1 over 2 y meters. So now we have to find at the point where which of the following combination will be correct when the pulse meet at the medium. So now the upper direction is positive and then the downwards direction is negative, so it's going to be y, 1y minus 1 over 2y, and then when you add them, it's going to be 1 minus 1 over 2, which is 1 over 2y. And then we can see that it's constructive because the positive direction, the upper direction, is the constructive, the positive one is the constructive interference, and the negative part is the destructive interference. And then whenever we look at our final answer is positive, so it means that it's a constructive interference of 0.1. So therefore option C is the correct one. So now, which of the following is correct for the sound wave? So let's look at option A. So which of the following is correct for sound waves? Option A, travel faster in gases than solids. And let's look at option D, travels through a vacuum. So it travels faster in a gas than in a solid. Let's look at solids. Whenever you look at solids, waves can never pass through a solid, but in a gas. But let's look at vacuum. Vacuum is like air, in air. Whenever I'm talking right now, my sound is moving through air. This means that option A is definitely correct. And then let's look at option option C. To travel faster at low temperatures. Now, and then longitudinal waves. So remember, longitudinal waves are those ones, and then sound waves are represented by there's an example of a sound wave. So this means that option D is the correct one. So let's look at formulas now. Formulas of sound waves. Just go to a formula sheet. It's always given in the back of the formula. So we're going to use table 2, wave, sound, and light. So these are the formulas for wave, sound, and light. Right? So now let's look at what is given. We're given the time it takes from point A to move to Q, which is m seconds. We're given the period, the time, m seconds. And then we are looking for the frequency. Let's look at formula A. Formula A, we're given the velocity, the frequency. We don't have velocity. You can even see in the question, we don't have velocity. And then this means that option A is wrong. And then energy. We are not given the energy in the formula. And then obviously the Planck's constant is given, but the energy is not there. So this means that option is wrong. And also that's an energy question, so it's wrong. So we're left with only T. We're given T, the period, and then we're looking for F. We can use that. T is equals to 1 over F. And then we can substitute our T, which is m seconds, and substitute m equals to 1 over F. And then we can solve for F. Make F the subject of the formula. We'll say over 1. And then we cross multiply. M times F, which is Fm, equals to 1 times 1, which is 1. And then divide by m both sides. And therefore F is equals to 1 over m hertz. So this is our answer. Therefore option D is the correct one. Option B is the correct answer for this question. Remember, look at what's given. Look at what's given. We're given the period, and then we're looking for f. That's why we found option D is whenever n happens. Now, which of the following will result in an object becoming positively charged? Now, ions. Let's look at magnesium and magnesium 2 plus. Magnesium 2 plus. So, what are N ions and what are cation ions? So, what we know about cation ions are particles that are negatively charged. N ion is a particle that is negatively charged. So, is the charged particle that is made by gaining of electrons. So it becomes negatively charged. So let's use magnesium. Magnesium G2 minus. It gained electrons. So it's an N ion. It's a negatively charged. So it gained electrons. So cations will basically be the opposite. So we'll basically just say is a charged particle that is made by the loss of electrons. So this is a cation. So let's look at that one. Option positively charged loses electrons. So option B is the correct one in this case. Option B is the correct one. Let's look at question 1.5. Question 1.5, it talks about, in the second diagram, the resistance. Resistor A is double resistor of B. Which of the following is correct relation of the charge through resistor A? We're talking about the charge through resistor B and the charge through resistor A and the charge through resistor B. So now, what is the charge? So now, let's talk about the term charge. What is charge in this case? So now, let's go to electricity. A charge. You have to understand what is a charge. A charge is measured. So let's look at V equals to and V equals to I times R. I is the charge. I is always the charge. So we have a definition of a charge. So a charge is the rate. Current is the rate of charge. Meaning current, I is current, which is measured in amperes. So now this rate of charge is basically is derived from Q equals to I times, so I times T, then you make I the subject of the formula, and then I is equals to Q over delta T. This means that I is the rate of charge. Q is charge, Q is the charge, and then delta T. So let me try making this simple. So from the formula, we're just gonna make I as our charge, the subject, and divide by delta T, and then I will be given by Q over delta T. That's the rate of charge. This is the rate of charge. This is basically the current, the definition of a current. When I say define what is current, you just say current is the rate of charge. Current is the rate of charge. Let me just share my screen. So we're here. Current is the rate of charge, and then which is measured in amperes, A. And then let's look at the two formulas. They both consist of I. They, they both have I. Let's look at the other formula, which is V equals to I times R. So they both have R. So let's make I the subject. I will divide by R both sides, which is V over R. These are the two formulas of current, which is the rate of charge. So we'll choose between the form. It depends on what do they want. So now you're given the resistance. So which formula would you use? Given R, so the formula we'll be using, it's I equals to V over R. So in this case, we are going to ignore V because it's not given. So just in the place of V, we'll put 1. And then for R, for the charge of A, we'll use 1 and then 2R. And then in the place of current of B, so this is basically 1 over 2, right? And then this is going to be 1 over 1, which is 1. So the charge of B is 1 and the charge of A is 1 over 2. Option A, this is disconnected. Okay, let me just share my screen. So the charge, we were saying that the charge through A, option A, the charge through A is double the charge of B. This means that this is wrong, definitely wrong. The charge through resistor A is half the charge of resistor B, which is true. We already calculated that. So let's look at question 2. Question 2 is the tricky one. This is the tricky question. We're given the frequency and the speed in this question. So we're going to define what is a transverse wave. So a transverse wave is a wave in which the distribution is at right angle to the direction of the propagation of a medium. So you will see if we put a particle here and then the direction of the medium is to the right, we can see that the charge is at right angle to the propagation of the medium. This means that that's the definition of a transverse wave. So x is the wavelength, y is the amplitude. Yeah. Now the main question, given the frequency and the velocity, you're supposed to find the lambda, the wavelength. So we're going to use the first equation, which says that V equals to frequency times lambda. Then we substitute 10 equals to 20 times lambda. And then we're going to make lambda the subject of the formula. We're going to divide by 20 on both sides. So then we're going to divide by 20 both sides. And then therefore lambda is equals to 0.5 meters. So yeah, the next question says that determine the time between point A to point B. Determine the time between point A and point B. Here we have many ways to kill a cat. So we have two formulas. We are supposed to find the period T, and then we're supposed to find. So there are many. So what is the distance between A to B? A to B. How many waves are here? So we have the first wave, the second wave, and the third wave. So in this case, we have 3 waves. So point A to B will move 3 times. So this means that there is going to be 3 times the wave. So the wavelength from A to B is going to be 3 times 0.5, which is 1.5 meters. And then another one, we already know the speed of the wave. It's given as 10 meters per second. The speed is given as 10 meters per second. So now we already have the velocity, we already have the lambda. We're supposed to find the frequency. We find the frequency. Velocity equals to lambda times frequency. 10 equals to 0.5 times frequency. And then we can solve for f. Therefore, f is equals to, now it's going to be 1,666. 6,66. Yeah, 6,66 hertz. And then now we have the frequency. We can use the period formula 1 over f. Therefore, y equals to 15 seconds. Now 0.5 seconds. It's gonna be 0.5 seconds. This is the frequency. So there's also another method. So let's try and see what's happening. What is happening here? The first thing, we have to use what's given on what we calculated on 2.3.1. So when we got wrong on 2.3.1, the whole thing is wrong. So we have wave number 1, wave number 2, and wave number 3. So the first thing you have to know is the distance. You have to know that from A to B is 3 times the wavelength. And another thing is the speed. This is method number 2. We're going to use distance equals to speed over time. Distance equals to speed over time. We have distance as 1.5 and velocity as and speed as 10 meters per second. We can say now this is speed equals to distance over time. And then we already have the speed. The distance. The distance is 1.5 and the speed is 10. So now we can substitute and find time. This is method number 2. This is method number 2, guys. Don't get confused. We have many ways to kill a cat. Remember, 2 many ways. So velocity is 10. Okay, where there is v, you can put a 10. And then where there is distance, you can put 1.5 meters. And then you can just cross multiply. Time is equals to 0.5 seconds. Thanks, guys. This is the end of the lesson, and this is method number 2. Just a reminder, guys, method number 2. We have method number 1 and method